Hello everyone. Today I am going to discuss JEE Main 2022 chemistry paper of SHIFT-1 which was held on 27th of June. So let's start with the first question. It's white phosphorus treated with concentrated nitric acid. What is the product? So concentrated nitric acid is a very powerful oxidizing agent. We can say it's a powerful oxidizing agent and it oxidizes these nonmetals to its ic acid. So phosphorus will get oxidized to phosphoric acid. Okay, so you can see that phosphoric acid is basically H3PO4, where the phosphorus is in +5 oxidation state, and itself nitric acid from +5 oxidation state itself will get reduced to +4, that is NO2. Okay, so the correct answer for this will be option C, that is phosphoric acid and NO2. Let's see the next one. Yeah. Question is, match the molecules given in column A with their corresponding shape in column 2. Okay, so column 1 and column 2, these are the molecules and these are their shapes. These are very common molecules. First, SF4, we know is a CSO. SF4 is CSO, so it will be matching with Q. BF3 or BCl3 is trigonal planar, so it will match with R. XCF4, that is your square planar, and CLF3 is the T shape. So if you see, the correct answer is first one. Now let's move to the next one. Which of the following has the maximum CFSE value? And CFSE value is simply directly proportional to strength of ligand. So in this case, ligand is water. Here it is water. Here it is water. But in this case, it's cyanide, which is a very strong field ligand. The correct answer should be third one. Let's move to the next one. Okay, this is a simple question that is based on the preparation method of BeH2. Okay, so BeCl2 is treated with lithium aluminum hydride, LiAlH4, that will give H minus, and it will replace the chloride ion from BeCl2 and will form BeH2. So one of the product is BeH2, and you can see here it is. And other product is this Cl minus will be interacting with Li plus to form LiCl as well as with aluminum to form LCl3. So it is the second one that we will be getting direct from NCERT. You can see that reaction is in S block. Next, fifth one, statement 1. Classical smog is formed in cold and humid climate. That is perfect. That is correct statement. And the second one is photochemical smog contains ozone and pan. This is also correct. Ozone, pan, aldehyde. Okay, these are basically NOx. These are basically constituent of photochemical smog, which are oxidizing in nature. So the correct statements are basically both 1 and 2. Both 1 and 2 are correct. So it's the first one. Let's move to the next one. Question number 6. O2 minus and Mg2 plus have same ionic radii. That is incorrect because they have same number of electron. They are isoelectronic. They have 10 electron. But if you talk about the size, O2 minus will be bigger in size than Mg2 plus. This is the ionic size. Now, they are isoelectronic species, so this is correct. So statement 1 is false and the statement 2 is true. So it's the fourth option. Statement 1 is false and the statement 2 is true. Let's move to the next one. Let's see the question number 7. It is basically PHS minus, that is a nucleophile. Now, this is the living group. It can leave and this can attack. It will be purely SN2 pathway because this is a strong nucleophile. Okay, and the correct product will be the third one. You can see this is your correct product. Coming to next. Match the column 1 having process and the elements with their corresponding ores, reagent or process used in extraction. Column 1, blister copper. Blister copper, basically we do electrolytic refining. Okay, so the first one will match with Q, that we do electrolytic refining for the blister copper. Other, it's sulfide ore, that is okay because it is coming from copper pyrite, that is UFES2. So its ore is sulfide ore, so it will be Q and P. Okay, so here this is wrong, this is wrong, this is correct, this is correct. Okay, let's check the another one. Froth flotation. Basically, this process we do for the sulfide ore, so it will be P. Okay, P only because so in this case it is gone and this is correct. So correct answer should be the second one. I check the last one also. Gold extraction. We make the complex, that is complex of gold that is present in McArthur forest cyanide process, that is R. So coordination number of this complex is 2 and gold is in +1 oxidation state. So this is R, one of the match for that. Okay. And electrolytic refining we can do for gold as well. Okay. So it's the Q also. So the correct answer should be the second one. Now, question number 9. What is the product found when barium peroxide? Barium peroxide, that is basically BaO, it's treated with sulfuric acid. Treated with sulfuric acid. So peroxide, when will be treated with acid, you will be getting salt, that is BaSO4, plus H2O2 plus water. Okay, so and this barium peroxide basically exists in this form BaO2. I'm sorry, BaO2, that is barium peroxide. BaO is barium oxide. It exists in the form of BaO2 dot H2O solid. And this is one of the method to generate what? Hydrogen peroxide. Okay. So the correct option for this is option number C, that is barium sulfate and hydrogen peroxide. Other peroxide as well will give the same. Suppose we have sodium peroxide like Na2O2, and if you treat with sulfuric acid, we'll again get the salt of sodium, that is Na2SO4, plus hydrogen peroxide plus water. Okay, let's move to the next one. Question number 10. We have to match the column basically. Okay, so what is emulsion? Emulsion is basically liquid solid. Okay, like oil in water, water in oil. So it is not matching with A or B. Other options is here. Yeah. So emulsion is liquid solid. So A is matching with D. Now let's move to the next. Next we have positively charged colloid. Okay. Positively charged colloid. If we have FeCl3 and NaOH, it will form FeOH whole thrice. And then OH minus will get adsorbed on that because it is NaOH basic medium. So it will be forming negatively charged colloid. It will be forming negatively charged colloid, not positively. So let's see the positively charged colloid here. Yes, it should be FeCl3 and hot water. Cool. So it will be 2 will be matching with C, and this is first, which matching with D, because FeCl3 with water will give you FeOH whole thrice, and then on this iron 3 plus ion will get adsorbed. Okay, so that will be positively charged colloid. Now negatively charged colloid already we have seen, that was in the second option, so 3 will be B, and the 4 lyophilic colloid. Lyophilic will be the first one, that is a protective colloid. Lyophilic are self-stabilizing colloid and they are protective in nature. So it will be DCBA. DCBA. So here it is mistake, here it should be A and your answer should be the first one. Next, this is directly based on application of the polymer. Polystyrene is basically used for wrapping material. Polyvinyl chloride is used for PVC water pipes basically, so it is water pipes. Glyptal is for paints and lacquers. Already it has been asked in JEE previously. Glyptal, very important. And bakelite is for electrical switch. Okay. So if you see, the correct answer should be Option E. 1 is 3, 2 is 4, 3 is 2, and 4 is 1. Simple question, and that is directly again from NCERT. Okay, one table is there in which the polymer applications are given. Now, which of the following is a separating funnel? They are asking you the separating funnel. You can see all these 4 figures here. If you see carefully, the first figure itself is the separating funnel. This one is separating funnel. The second one is burette. The third one is a round bottom flask. And the last one is a conical flask basically. So the correct answer should be the first one. Let's move to the next one. That's the question number 13. Okay, a compound A which is undergoing reductive ozonolysis is giving you glyoxal, that is CHO, and butane 1,4-diol. So 1, 2, 3, 4 butane 1,4-diol. This one. Okay, aldehyde. Compound B is giving you 5-oxohexanol. So 1, 2, 3, 4, 5, 6. It is al, and 5-oxo is this one. So compound A and B are respectively. So that is very simple. Since we can club them together and we'll get the species that we have, also we can club them together. So there is carbon-carbon, double bond oxygen. So you can see, you can club them together. So it will be like carbon. How many carbon are between? 1, 2, 3. So 1, 2, 3 carbon in between. Okay. 3 carbon in between. And this carbon should be in contact like this. And this methyl group will be the substituent, and this is hydrogen. Yeah, if you're clubbing them together before ozonolysis, you'll be getting like this. So if you see, it is matching with what? This one, this B. So B is this one basically. This is your B. Now coming to first one. If you break this one, then you will get glyoxal. You will get 2 product. First product you will be getting is this one. And other product you will be getting is this one, glyoxal. So the A is simply this one. That is very simple, directly pushed on what reductive ozonolysis. So A is your this one. So correct answer is B. That is the second option. Let's see the next one. Question number 14. Now a compound X having 4 carbon atoms can react with 3 moles of acetate ion during acetylation reaction. The compound X also gave positive Tollens test. It reacts with bromine water to form an optically active compound, but reacts with concentrated nitric acid to form optically inactive compound. What is X? Okay. So first it is having 4 carbon atoms. So 1, 2, 3, 4. Each one is having 4 carbon atoms. Okay. It can react with 3 moles of acetate ion. 3 moles of acetate ion. It can react. It means it should have 3 OH group. In place of acetate ion, yeah, it is basically esterification reaction. So 3 mole, it will undergo esterification. So 3 OH group, all has 3 OH group. Okay. Now the X also gives positive Tollens test, means aldehyde group should be there, all are aldehyde. It reacts with bromine water to form optically active compound. Okay. So bromine water will convert this CHO to COOH. Okay. Here also it will convert CHO to COOH, and here also it will convert COOH. But this is what optically inactive. Optically inactive. Why? Because it is having plane of symmetry. So this is not the answer. Okay, let's move further. It reacts with bromine water to form optically active compound, but reacts with concentrated nitric acid to form optically inactive compound. So if you react it further with concentrated nitric acid, then the top group will also get oxidized and the bottom group will also get oxidized to carboxylic acid. And now it is becoming what? Now it is becoming optically inactive because plane of symmetry is there. Optically inactive because plane of symmetry is there. So this is again eliminated. Now if you treat this with the concentrated nitric acid, okay, wait a second, this is not discarded. Wait a second. COOH, and this is OH, OHH. This is still optically active. This is still optically active. And this is what? Optically inactive. But it is saying that HNO3 to form optically inactive compound. So your correct answer should be the second one. Okay, so for 14th, it is the second option. Let's see the next one. 15. Consider the following statement regarding Hofmann-bromamide degradation reaction. Statement 1. One alkyl group migrates from the carbonyl carbon to nitrogen atom. This is true. That is in the basically rate determined step of Hofmann-bromamide degradation reaction. Next, migration of alkyl group takes place towards electron deficient nitrogen. So that is also true. Simple. If you see what is happening here, this is the intermediate. If the migration occurs, this will go, then this nitrogen will become nitrene, that is electron deficient, then this alkyl group will migrate. So the migration of alkyl group is taking place towards electron deficient nitrogen. This is also true. Okay, so the correct statement is what? Both 1 and 2. That is the first one. Now that's directly match type question. Okay, so you can see here they're asking you match the following. Laundry soap filler. Basically the soap filler that is used is sodium rogenate. Okay, so sodium rogenate or sodium carbonate. So A is going to match with what? A is going to match with this fourth one. Okay, now hair conditioner. Hair conditioner is basically a cationic detergent, that is cetyl trimethyl ammonium bromide. So B will be matching with this. After that, liquid dish soap is liquid dishwasher is basically non-ionic detergent already. It's all are given in NCERT. Okay, so C is matching with 2. And the last one, that is D, the household detergent is sodium dodecylbenzene sulfonate. So last one will be matching with 3. So if you see, the correct option is option E. A will be matching with 4, B will be matching with 1. Liquid dishwasher is non-ionic detergent, that is 2, and D is 3. Let's move to the next one. That is question number 17. What they're asking, see, the change in the angular momentum during transition of an electron from ground state of hydrogen atom. It is given that electron absorbed 10.2 electron volt energy during the transition from the ground state to excited state. So you know that ground state energy is how much? Minus 13.6 electron volt. And first excited state energy is how much? Minus 3.4 electron volt. So if the electron will given the energy that is equal to plus 10.2 electron volt, then it will undergo transition from n equal to 1 to n equal to 2. Now the electron is present in the second orbit. Earlier it was in the first orbit. Okay. What is the angular momentum? That is MVR. MVR is equal to NH upon 2 pi. So initial angular momentum is H upon 2 pi because it is present in ground state. Second angular momentum final is 2H upon 2 pi, that is H upon pi. So what is the difference? Basically they are asking the change in angular momentum. So 2H upon 2 pi minus H upon 2 pi. The difference is what? H upon 2 pi. And that's the second one. Very simple question. Let's see the next one. That is question number 18. Now, Fe0.930 has metal deficiency defect. Calculate the percentage of iron 2 plus in this. So in this case, we have iron as iron 2 plus as well as iron 3 plus. They are asking you the percentage of iron 2 plus. So let iron 2 plus amount is X. So iron 3 plus will be how much? Total is 0.93, so it will be 0.93 minus X. Now to find their corresponding amount, we need to balance the charge. So now let's do the charge balance. So total positive charge is 2 into X because iron 2 plus is X in number. Now total positive charge due to iron 3 plus is 3 into 0.93 minus X. That will be equal to total negative charge, that is minus 2. So we can just write 2 and we have to just solve it. So it is 2X plus 0.93 into 3 is 9, 2.79 minus 3x equal to 2. So it will be x equal to basically 2.7 minus 2, that is 0.79. So this is the amount of iron 2 plus and they are asking what percentage. So percentage iron 2 plus is what? Amount of iron 2 plus, that is 0.79 by total amount, that is 0.93 into 100. That we need to do basically to find the percentage and it will be coming close to 85%. So that's the answer for this one. Correct answer should be 85%. Let's see the next one. Find the spin only magnetic moment in ore magneton of manganese containing a species which is formed by KMnO4 in acidic medium. KMnO4 in acidic medium, basically it gives you Mn2 plus. In neutral or weakly basic medium it goes to plus 4 and in a strongly basic it goes to plus 6. So it is Mn plus 2. Mn plus 2 is what? If you do electronic configuration it will be argon, 4s0 and 3d5. So it has 5 unpaired electron, then magnetic moment is what? Square root of n into n plus 2, that is the square root of 35 bm. Yeah, and 35 bm will be approximately 5.9, so we can just take it as 6 bm because we have to take this value in integral form. So that is the final answer, 6 bm. Now the next question, what is the molar conductivity of AgI at 0 concentration, that is infinite dilution, if the value of NaI, AgI, AgNO3 and this are given? So we have to simply use the Cole-Ross law. So we can just write AgI as limiting molar conductivity of your AgNO3 plus limiting molar conductivity of your NaI, yes, minus limiting molar conductivity of your NaNO3, sodium nitrate. Okay, so AgNO3 molar conductivity value is 16. Okay, plus NaI, that value is 12 minus NaNO3 is 10. So it will be 28 minus 10, that is 18 Simon centimeter square per mole. Okay, so the correct answer should be what? 18. Now, next question, we have to consider the equilibrium that is given in the next page. Yes, we have to consider this equilibrium. The reaction is started with 2 mole of NaCl in 1 liter closed container and allowed to attain equilibrium. At equilibrium, the moles of NO was found to be 0.4. Then the equilibrium constant value is this much. Find the value of X. So it is very simple. We'll just write 2 NaCl gas giving you NOs, 2 NOs plus Cl2 gas. At t equal to 0, we have started with 2 mole of NaCl. Okay, it is 0, 0. Now, at equilibrium, moles of NO was found to be 0.4. So 0.4 it must have reacted so that it is forming 0.4 and it will be forming 0.2. You can see the mole is same here, coefficient is same. So same amount will be formed and here coefficient is just half of that, so it will be 0.2. Simply mole concept. So at equilibrium, NaCl amount is how much? 1.6. NO is 0.4 and Cl2 is 0.2. Okay, and this is 2 mole in 1 liter, so we can also write 2 molar concentration. So this is in molarity as well because the volume is 1 liter. Now they are asking you the Kc. Kc will be what? Concentration of Cl2 into concentration of NO to the whole square divided by concentration of NaCl to the whole square. You see the value here. Cl2 is 0.2, okay. NO is 0.4, a square means 0.4 into 0.4, and here NaCl square means 1.6 into 1.6. Simply, okay. So here it will be 4 times, here it will be 4 times. Okay, so it will be what? If you just solve it, 2 divided by 160. 2 divided by 160. So if we do the calculation, we'll be getting 0.0125. And that can be written as what? If you just write it, we can just write it as 12.5 into 10 raised to minus 3. Okay. So basically the value of x here is what? 12.5. That's the final answer. Now let's see the next question, and that's the last one. Calculate the wavelength in angstrom of the radiation absorbed during the transition of an electron from ground state of lithium 2 plus to second excited state. So ground state is n equal to 1 and second excited state is n equal to 3. Okay. So what is the energy of lithium? Okay. In the ground state, basically they are asking you wavelength. Okay. So we'll just use the Rydberg equation. We have 1 upon lambda equal to Rg square 1 upon n1 square minus 1 upon n2 square. Okay. Now 1 upon lambda R Rydberg constant, that is Rh, and G is the atomic number for hydrogen, helium, lithium. It is 3 square. Now 1 upon n1, it is going from first to third orbit, so it will be 1 square minus 1 by 3 square. So it will be how much? Rg into 9, and this will be 9 minus 1 by 9, that is 8 by 9. This 9 will get cancelled out. So it will be 1 upon lambda equal to 8 into Rh. Okay. So lambda will be equal to what? 1 upon 8 into Rh. Okay. So we'll just put the value 1 upon 8 into Rydberg constant value is what? 109677. Okay. That is centimeter. So if you just solve it, we'll be getting 1.14 into 10 raised to minus 6 centimeter. And we want in angstrom, then we can just write it as minus 8 centimeter or 114 angstrom. Because 10 raised to minus 8 centimeter is your 1 angstrom. So this is the final value for this, that is 114 angstrom.